Hello everyone. Today we are going to see a lecture on turtle programming. Turtle programming in Python with the module which we will be discussing is graphics and GUI programming, drawing using Turtle. So Turtle is a Python-like feature. It is like drawing on a window, which lets us command a turtle to draw all over it. We can use different functions in Turtle, like turtle.forward, turtle.backward, different angles like turtle.right, turtle.left, which can move the turtle all around. There are different methods which are commonly used in turtle programming. The first one itself is turtle. It creates and returns a new turtle object. Then turtle.forward, and in the parenthesis which you can write the amount which it needs to travel. Turtle.backward, it will again need the amount to which it can travel backward. Then right, left, these are the angles by which the turtle object will take an angle. It will move right or left. There are different shapes of turtle. Usually by default it is having arrow. You can use shape like classic, turtle, or circle. It is having different colors, so in the parentheses you can write the name of the color you want the background to be, or the color of the turtle to be. Then there are the fill color, then heading, different colors are there, and there are so many other functionalities or methods which are there in Turtle. The next thing which comes is that how we can plot using Turtle. To make use the Turtle methods and functionalities, we don't need to install any package of Turtle. We only need to import Turtle. Turtle is already present in the basic Python, so you don't need to externally install any kind of packages. Turtle comes packed with the standard Python package and not be installed. The roadmap for executing a Turtle program, it follows 4 steps. The steps are: first you need to import the Turtle module, then create a turtle to control it, then draw around using the Turtle methods, the list of methods which we discussed previously, and there are many more methods as such. And finally, as you are completing the program, before that you need to write turtle.done. So you must remember that you need to write turtle.done to execute the program. Before we can use Turtle, we need to import it. So the import can be done in 2 ways. That is, you can simply write import Turtle on the topmost portion of your editor, like idle or PyCharm, anyone which you are using. Otherwise you can write from turtle import star. After importing the Turtle library and making all the Turtle functionalities available to us, we need to create a new drawing board and a turtle. Let us call the window as we need to name the drawing board, so we are naming it as with the name WN, and the turtle object as SKK. Now let's see that how we can code it. WN is the name of the window, so we are writing WN is equal to turtle.screen. That means in that particular area you can draw whatever images, pictures, or drawings you want to draw. Then window dot background color, so you will be giving the background color of that particular window. Then window dot title, so whatever title you want to give, over here we are giving the name as turtle itself. And then finally you are creating a turtle, so that you can use that particular turtle to draw any object, any figures. So skk is equal to turtle.turtle. Now that we have created the window and the turtle, we need to move the turtle. To move forward 100 pixels in the direction skk is facing, we code skk dot forward, and the amount is 100 pixels. So you need to remember the amount over here is in pixels. We have moved skk 100 pixels forward. Now we complete the program with the done function and we are done now. So at the end of the program we will be writing turtle.done. So we have created a program that draws a line 100 pixels long. We can draw various shapes and fill different colors using turtle methods. There are various functions and programs to be coded using the turtle library Python. Let's see few of the examples. So this is the first turtle program, simple turtle program. So what we are doing over here in ITIL, you can see import turtle first, which is completed. Then we have created a window or a screen where we are going to draw. So we are naming the object as wn is equal to turtle.screen. By that we are creating the window. Then the background color of that particular window will be light green. So in the arguments we are writing light green. Whatever color you want to write, you can write that particular color name over there. Then the title of the window, we are writing turtle. Then skk is equal to turtle.turtle. By that we are creating the object turtle. Now skk.forward, that means from the origin it will move in the right direction by 100 pixels. And finally turtle.done. By that we are completing this particular program. Now let's see the after execution that what is the result. We need to save our program first. You can see from the origin this has traveled 100 pixels over here and it is having a arrowhead. Similarly, we can write different programs. The second program which we are going to draw as or code as square turtle. Again we are importing turtle. Now we are naming the turtle object as skk. So then turtle.turtle. Then we are using for loop over here because square has 4 sides. So for I in range and the argument we have given 4, that means for loop will run execute for or iterate for 4 times. Then skk dot forward 50 pixels, then skk dot right 90. That means over here you can recollect that right when we are using that it signifies angles with which the turtle object will move. So we are keeping it 90, that means it will take an angle of 90 degree. Then turtle.done. By this we are completing the program. Now after execution you can see that what is the result. So you can see we have created one square. It is the origin. From here it has traveled 50 pixels. After that it has taken right turn, that means 90 degree turn, and then again a 90 degree turn and again a 90 degree turn. By this it has created a square. Similarly you can draw a turtle star. Import turtle. Star is equal to turtle.turtle. Over here we have given the name of the turtle as star itself. Then again for loop we have used for I in range of 50, that means it will iterate 50 times. Then star.forward, it will go 50 pixels. Star.right, that means it will take a degree turn of 144 degrees. Then turtle.done. Let's execute this program. You again wish to see this particular program, then you can pause and listen it again. So you can see this particular turtle object is iterating for 50 times. It is the origin. It has traveled 50 pixels. Then it took a 144 degree turn. Over here 50 pixels again it traveled. Again it is getting a 144 degree turn. Like this ways it will keep on doing for 50 iterations. The next program is turtle hexagon. Again we are importing turtle. Then hexagon, that means it can be a polygon. That means there can be any number of shapes, sides it will be having. Polygon is equal to turtle.turtle. We are creating the object as polygon itself. The number of sides, since it is a hexagon, it is having 6 sides. Then the length of each side will be 70. and the angle depends upon, there are total 360 degree divided by number of side it is having. That means angle is equal to 360 divided by number of side. Then again, for I in range, we need to write the range, so we are writing number of side. Then polygon dot forward, side length, the length of the side is 70 as it is mentioned. Then polygon dot right, the angle we need to mention over here, so the angle is 360 divided by number of sides, so directly the angle will come over there. So total dot done. Finally, after executing this, we can see that there is some error. We need to see this. What's the error? So after execution, you can see that as we are executing it, so a hexagon is created over here. Similarly, other programs you can do. The next program that we are going to do is spiral square outside in a square. A bigger square is at the outside, and we are going to have a smaller square inside it. So first of all, we will import the turtle. Then we will create one window, that is window is equal to turtle.screen. Then window dot background color is light green. Then window title will be turtle. Then skk turtle dot turtle, with that we are creating the turtle object. Then skk dot color, that means the object will be blue in color. Now we are having an inbuilt function, that is square function. So define a square function. The size will be given over there of the square function of what we want the square of. Then for I in range, square is of size 4. Then skk dot forward, that is size. Then skk dot left, that means it will go towards anti-clockwise 90 degrees. And finally we are keeping a decrement operator, that is size is equal to size minus 5. Therefore whatever the size will be there, after the completion of the 4 sides, 5 will be reduced from the size. So over here we have a set of square functions with different sizes, like a square function 146, 126, 106, 86, 66, 46, 26, turtle dot. Then finally let's execute this particular program. Now we can see that square is created, and you can see minus 5. Okay, and by this there is outside in, that means there is a bigger square outside, and minus 5 size, that means total 4 times 5 times 4 times. If 5 is reduced, you can see that a different square is created at the end. Now what if we are doing one thing? You can see this particular result, and a result by which we are going to edit it with it. We will save it, and again we will execute this particular program. You see the difference between the two. So a square is built, but now what you can see, that the difference between the second square and the third square is quite smaller. So by this we can say that we need to choose our square function correctly. Therefore we will be keeping it 26. Okay, thanks for watching. We will again get back to you with the next set of programs. Thank you.